So the final two problems that we had in section 2.2 I've worked out here. This second problem here is similar to the first. The first problem we worked through dealt with bird strikes of airplanes. This problem that we're dealing with deals with a number of students who have taken the military's aptitude test. You'll see here it says this: the number of students who have taken the military's aptitude test has decreased approximately linearly from about 857.6 thousand students in 1999 to about 539.3 thousand students in 2007. It says let n be the number of high school students who have taken the test in the year that is t years since 95. Find an equation of a linear model to describe the data. First thing I did was I wrote down y equals mx plus b because it says I'm supposed to find a linear model. That's the y equals mx plus b. Second thing I did was I organized my data points. I know xy is the generic independent dependent, but I've been given the variable t and the variable n. Now t is independent and n is dependent. The number of students who take it is dependent upon what year it is. So t is my x, n is my y. So I look at my first data point here, and that is that there's 857.6 thousand students in 1999. So in that case, my n is the 857.6, and my t is 4. The reason 4 is 1999 is 4 years since my starting year of 1995. The next data point I see is that there's 539.3 thousand, that's 539.3 thousand in 2007. My t for that is 12. Why 12? Because 2007 is 12 years since 1995. So I know I have to fit my data to the y equals mx plus b. To do that, I first start with the slope formula. That is that my slope m is equal to y2 minus y1 all over x2 minus x1. So I chose the bottom point as my second point, the top point here as my first point. So 539.3 minus 857.6 all over 12 minus 4 leads to negative 39.8. So I take that slope, which is the slope between these 2 points, and I plug it into the m of the y equals mx plus b. Now to find the b value, I take one of my data points. I chose the first for 857.6, and I plugged it in for the y and the x. I plugged in 857.6 for the y, I plugged in 4 for the x. I was able then to solve that for b. In solving for b, I end up with b equaling 1016.8. Now I know both m and b. So y equals negative 39.8x plus 1016.8. But instead of x and y, I chose to use n and t because those are the variables that we defined. So really, n, the number of students who take the military's aptitude test, is equal to negative 39.8 times t, which is what year it is since 1995, plus 1016.8. The second question asks us to use the model. Using the model you've found, predict the number of students who will take the aptitude test in 2017. Now 2017 for us is actually 22 because we reference everything from 1995. So what we're going to do here is we're going to take 22 and we're going to plug it in for the t. So negative 39.8 times 22 plus 1016.8 ends up giving us, when we simplify it, 141.2. But we know our units are in thousands, so we know that 141.2 thousand students will take the military's aptitude test in 2017 according to our model. This last problem here is a little bit different, primarily because I'm giving you many data points. In the other two problems, you were only given 2 data points to work with. Whenever you're given 2 data points, find the equation by hand. However, when you're given multiple data points, 3, 4, 5, 6, or 7, what we want to do is we want to make sure that the every point we're given has an impact. Because what we're doing right now is, for the previous 2 problems, it was only selecting 2 points. If I were to only select 2 points from this graph right here, which is these points modeled, let's say I only pick these 2 points. A line through those 2 points doesn't model the rest of the data very well. Similarly, a line through these 2 points doesn't model the rest of the data very well. I want a line that doesn't necessarily go through any of the data points, but gets as close to all of them as possible. We can do it by hand, but it is incredibly intense. So what we're going to do is we're going to rely on our graphing calculator to help us use all the data points to find the equation that goes through all of these points up here the best. Okay? So what I did first was I converted years to years since 1980. So 0, 5, 10, 15, 20, 25, and 26. Now, I already got the output right here. Let me show you how I get that. What we're going to do is we're going to let the computer do the calculations for us. We're just going to give it the data and tell it what to do. So we want to hit this button that says Stat. So we hit Stat. This is similar to what we saw with constructing scattergrams on a calculator. We go Edit, Edit, and that gets us to the screen where you see column L1, L2, L3, so on and so forth. Now under L1, you'll notice that I put all of my years since 1980 data. That's because that's my independent variable X. I can't change what year it is, but the life expectancy changes based on what year it is. So my life expectancy is Y. Notice I put all of that in L2. Now if you forget how to clear out data, if you have data in there so you can put new data, remember you scroll up and highlight L1 or L2, hit the clear button, not delete, hit clear, and then the down arrow, and it'll all go away. I'm not going to do that because I already have my data in there. So with the data present now, what I can do is go back to Stat. This time though, I'm going to hit my right arrow to go over to Calc. And you'll see that option number 4 right here says LinReg. That stands for linear regression. In other words, finding a linear model that goes through all of the data. So that's what we want. I'm going to scroll down to option number 4, and I'm going to hit Enter. Those of you with an older TI-83, you won't see this screen. You're just going to see y equals ax plus b, or linreg y equals ax plus b. Hit Enter again. Those of you that have this screen show up, scroll down to Calculate and hit Enter again. And this is the output we end up with. You'll see that it's y equals ax plus b. This looks a lot like y equals mx plus b. The calculator just uses a instead of m. It's the same exact thing. It's a linear model. So it's telling us that a is approximately 0.16 and that b is approximately 73.7. Notice that's what I have written down right here. And all I need to do now is fit this into the y equals a times, or ax plus b. So what I do is I go y equals 0.16 times x plus 73.7. Lastly, we're asked to use this model to answer a question. Use the linear model to predict the life expectancy of someone who is born this year. So this year for us, that's 2015. Our years start in 1980. So for us, that's 35 years. So I'm going to let x, which is years since 1980, be 35. Plugging 35 in for x, I solve this and I end up with a y value of 79.3. So if you were born this year, or if a child is born this year, our model is predicting that they will have a life expectancy of 79.3 years. So this is a run through of the last two problems from section 2.2. Watch the video as many times as you need, press pause, try these on your own, and see what you can do.